Hello, ladies and gentlemen. Today we're going to take a look at adding and subtracting now. So adding and subtracting rational expressions. We're going to start with just part one here, which is going to be when we have like denominators already. So remember, our big goal is that we're learning how to simplify rational expressions accurately. So we need to perform operations and make sure our answer is simplified. And if we review what we've already done in terms of adding and subtracting regular fractions, I guess we would call them, we're talking about making common denominators or making sure that we have common denominators. So 9/6 plus 5/6 would make 14. 14 what? 6. And then we would go ahead after we have added them and simplify then. And then we would say, well, what can I divide out of the numerator and denominator here? Looks like I can divide them both by 2, so it becomes 7/3. So we simplify our answer towards the end here and make sure that it's in simplified form. So we're going to think about this idea of making sure that we have common denominators, and then where does that take us in the process of adding and subtracting fractions? So remember to think about it. We got to make sure we're talking about the same thing. I can totally take 3 cows plus 4 cows, no big deal. That's 7 cows. But 2 cows plus 3 ducks, that's a challenge because those are not like terms. So common denominators are a necessary part of whenever we add or subtract anything in terms of math. So in order to add or subtract rational expressions, today our focus is on like denominators. Go ahead and get this part in your notes. When you have like denominators, when they're already alike, we are simply just going to add or subtract their numerators. So the top of those fractions will just get added or subtracted together here. And then make sure your final answer is already in simplified form. And if it's not, we might have to do a little extra to make sure. So we need to make sure that we are adding and subtracting those numerators today if we have like denominators. We'll have 4 examples. Here's the first one. If I have 7 over 4x plus 10 over 4x, then what would I really have? Well, think about it. Do I have common denominators? Yes. We're talking about the same thing here. So we're just going to simply add the numerators. 10 plus 7 makes 17, and then the denominator stays the same. That's kind of the what we're talking about here, like the 6th in our first problem or the cows. Okay, we have 17 over 4x. Now, is there anything we can do to simplify this further? Can you divide the numerator and the denominator by 2 or by 3 or by 4 or by an x? No, this is my final answer. Okay, I have added the fractions together and that's as far as we can take it. Let's look at a second example where there may be a little bit more involved. So simplifying number 2 here. 10x over x minus 5 minus 15 over x minus 5. Again, notice the denominators are already alike. They both contain the factor x minus 5. So I don't need to do anything to make common denominators, and that means that I can just simply add or subtract the numerators. So 10x is now a numerator that I'm going to subtract 15 from. Can you subtract 10x minus 15? No, because they're not like terms. So I would just keep it as 10x minus 15. And then again, the denominator stays x minus 5. Now, is there something we could do further? Okay, remember when you simplify these, you cannot cancel terms. Okay, you cannot divide 15 by 5. These are terms. If we want to do any further simplifying, we have to be looking at factors. So can I factor the numerator here? Can I take something common out of both of those pieces? Yes, I can divide a 5 out of both of them, and then it becomes 2x minus 3. I have factored the top into 2 factors, a 5 and a 2x minus 3. And then the denominator stays x minus 5, which is already a factor of terms there. They're combining there to make that factor. So is there anything that I can, in fact, simplify when I look at it all broken down in its factored form? No. This is my final answer. Okay? Final answer. But I don't know that until I simplify or I factor out that last piece. Let's look at simplifying here, number 3. We need to make sure we have common denominators. Looks like we do. They are both x squared minus 3x minus 28. Both of those denominators are in fact the same. So now we add or subtract the numerators. So I'm going to make one big fraction here. We know the denominator is going to stay the same. Oops, 28. And then we're going to go ahead and add or subtract across the numerator here. I have an x squared and I need to subtract 12 and a negative x from that. So none of those are like terms. So what I would end up with here is an x squared minus a negative x, which would be like adding x, minus a 12 is subtracting 12. Okay, there we go. This is how my answer looks. Now, I have combined these two into a single fraction now, but through subtraction, because that's what I was supposed to do. But now I need to make sure my answer is as simplified as it can get. Be careful, you cannot cancel terms. We need to be looking at this in factored form. So now I need to factor each piece to see if there's more that can be done. So let's look just at the numerator first. X squared, x negative 12. That's a trinomial up there, AC method. What multiplies to make negative 12 and would add to make 1? 4x and 3x. If the 3x was negative, that would add to make 1. So we're going to go ahead and place him in the boxes here. AC method. Now taking out greatest common factor, and I can see that that numerator splits apart into x minus 3 and x plus 4. That's his factored form. Now if I do the same thing here with the denominator, what multiplies to make negative 28 and would add to make negative 3? How about negative 7, positive 4? So now I can do the same thing. Looks like that denominator splits apart into x minus 7 and x plus 4. Now that we look at him in factored form, you can see now that we can simplify by dividing up common factors or by canceling factors. So x plus 4, x plus 4, you can go, and that leaves me with a final answer of x minus 3 over x minus 7. That's my final answer, okay? So the common denominators were already there. We subtracted across the top. We split it apart to see if we can simplify it further. Let's look at a fourth example of this. Looking across the numerator and denominator, we are supposed to add these two fractions. We need to make sure we have common denominators, and we do. So my denominator is going to stay the same. 2x squared plus 3x plus 1 is the denominator. And now the numerator. The numerators, it looks like I'm supposed to add them. So I add an x squared plus an x. And now to see if I can take this any further, I need to be looking at factors. So I need to factor numerator and denominator to see what they're made of, to see if any of those factors can cancel. So numerator, let me see, that does not have 3 terms, so the best I can do there is a greatest common factor. Taking out an x would leave me with x plus 1. X divided by x is 1. Now the denominator looks like another AC method, again, trinomial. What multiplies to make 2? 2 times 1 is 2, a times c. What multiplies to make 2 and adds to make 3? 2 times 1 would do that, right? 2 times 1. So we'll go ahead and put the 2x and the 1x in those squares, and we'll go ahead and factor out the pieces. And now that I see every little thing that he's made up of here, I can see that his factors include a 2x plus 1 and also an x plus 1. Now when I see them in factored form and I look at the numerator with the denominator here, those are factors. So now I can say my final answer is an x over a factor of 2x plus 1. Okay, there's my final answer. So today we're going to continue thinking about like denominators, but eventually we're going to say, what if they're unlike? What do we do to make that happen, to make that like denominator thing happen so we can continue this process? But that's for later days, so I want to thank you for taking good notes.